In this video, we're going to be discussing how to multiply and divide by radicals. So multiplying radicals property that if you have an nth root of a and the same nth root of b, then you can put them under the same index radical and multiply them together. So for example, you have a square root and a square root. So therefore you can combine 3 times 12 is 36. And then exponents are added together. So this is x to the first and x to the seventh, so you will get x to the eighth. And now you can reduce. The square root of 36 is 6. And then exponents, like we discussed in the last section, you divide by the index. This is a square root, so you will divide the exponent by 2. 8 divided by 2 is 4. And so that would actually be your final answer in simplifying multiplies. These are both cube roots, which means you can still do the same thing, and you can put them all under the same radical. 3 times negative 9 is a negative 27, and then you have x to the 12th. Now you can take the cube root. The cube root of negative 127, the cube root of negative 27 is a negative 3, and then the exponents you divide by the index. 3 goes into 12 4 times exactly. Now, dividing radicals uses the same type of property as long as the number that is in the denominator is not 0. So again, make sure the index has to be the same. So cube root over cube root, so it does combine. So 32 divided by 4 is going to give you the cube root of a negative 8, which is the cube root of negative 8 is the number negative 2. Same thing, you can go ahead and combine by the cube roots. So you can make it all one cube root. 162 divided by 3 is going to be, I believe, 54. And then x to the 5th minus x squared is x to the 3rd power. Back in algebra, we discussed when you have exponents that are divided, when you have bases that are divided, the exponents are actually subtracted. So x to the 5th divided by x squared, 5 minus 2 is 3. Whole numbers you divide, 162 divided by 3 gives you 54, but exponents you would subtract. And the reason is if you have x to the 5th, that is x times x times x times x on top, x squared is x times x on bottom. These two cancel, leaving you 3 x's on top, which is why there was a 3 on top. Now, we can simplify this. What perfect cube goes into 54, which is 27? So the cube root would be 27 times 2, and then x to the 3rd. So the cube root of 27 is 3. You're left with a cube root of 2 on the inside, and then the exponent you divide by the index. 3 goes into 3 exactly 1 time. So your answer is going to be 3x with the cube root of 2. Now there's something called rationalizing the denominators. So there is a property out there that basically states that you cannot have a square root, cube root, you cannot have a radical in the denominator. So what you will do is you will actually multiply the bottom and top by that radical. And on top, square root of 2 times square root of 3 is the square root of 6. And on bottom, the square root of 3 times square root of 3 is the square root of 9. Well, the square root of 9 is the actual number 3. And that is how you would rationalize the denominator. Now in this one, I'm actually going to simplify this first before I rationalize the denominator. I'm going to go ahead and make it all 1. 2 divided by 10 is 1/5. And then x squared minus x is going to give me 1x on top because the exponent was bigger on top. And then there's a y on bottom. Now that I have the square root of x over the square root of 5y, now I can rationalize the denominator. So to do that, I'm going to multiply by the denominator, which is the square root of 5y. So on top, the square root of x times the square root of 5y will give me 5xy. And on bottom, square root of 5y times square root of 5y gives me the square root of 25y squared. I'll go ahead and actually just write that. And then what nicely happens is, that's the square root of 5xy. The square root of 25 is 5, and the index is 2, and so for the exponent, 2 goes into 2 one time. So basically what you're doing is you're getting rid of the square root, and so you'll end up with whatever is left underneath the square root in the denominator. So to practice, I would like for you to pause the video and attempt these 4 problems and then resume in order to see the answers. Okay, so for the first one, I'm going to go ahead and combine everything that I can. So on the outside, 5 times 3 is 15. And the inside, 2 times 2 is 4. And then you add any exponents. X and x to the third gives you x to the fourth. Y to the sixth and y to the 1 will give you y to the 7th. Now I'm going to reduce. This is a square root. Well, I know that the square root of 4 is 2. So I'm going to go ahead and multiply 2 times 15 to get me 30. And then I divide by the index. So the index is 2. So 2 goes into 4 2 times. So I have an x squared left. And then 2 goes into 7 3 times with 1 y left over. And that will be your final answer. Whatever you can pull out of the square root, in this case it's a 2, you will multiply by anything that's on the outside. So 2 times 15 gives me 30. For the second one, I'm going to combine them into the 1 full cube root, which would give me a 16x to the 6th and y to the 14th. Now, first for the whole numbers, we need to think of all of the perfect cubes to figure out what might go into 16. So 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. So 8 goes into 16. So I do know that 8 is a perfect cube. So 8 times 2 will give me 16. And then I'm going to also write out the variables. The perfect cube of 8 is going to give me a 2. And I'm left with a cube root of 2 on the inside. Then you do the exponents, which is divide by the index. So 3 goes into 6 2 times, and 3 goes into 14 4 times, but there are 2 y's left over. Again, because 3 goes into 14 4 times. 4 times 3 is 12, so there are 2 left. So that is why there's a y to the 4th out front. But this 2 means that there are 2 y's remaining on the inside of the cube root. Next, I need to go ahead and simplify the x's and the y's first. So I'm going to write the 5 over 2 out front, and the 2 over 3 are going to stay in the numerator and denominator, but the x's I'm going to subtract. 1 minus 3 is 2, and it stays on bottom because the bigger exponent is on bottom. And then 3 minus 1 is also a 2. Now, I can further simplify this by dividing by the index with the exponents. You cannot take the square root of 2 or the square root of 3. So I do know that the square root of 2 divided by the square root of 3 is still going to be there. But because this is a square root, I can divide. 2 goes into 2 1 y times, and 2 goes into 2 1 x times. Now, we are not done because we still have a square root that is in the denominator. So we are going to multiply by the square root of 3. So on top, I'm going to be left with 5y square root of 6. And on bottom, I'm going to be left with 2 times x times 3, which is 6x. Why is that 3? Because square root of 3 times square root of 3 is the square root of 9, and the square root of 9 is 3. And 3 times 2 gives me 6. And the last one is very, very similar to one we just did. I'm going to simplify the variables first. So the 4/5 I'm going to keep, but the square roots will be 3 over 2. X squared minus x gives me x, and then y to the 1 minus y to the 5th will give me y to the 4th. Now, I can go ahead and get rid of some of these exponents at least. I do know that 4/5 is going to stay 4/5. You cannot do 2 goes into 1. You cannot simplify that, but 2 as an index goes into 4 2 times. 2 times 2 gives me 4. So a y squared will go out front. The square root of 3x stays, and then we have the square root of 2 right here that's left. The only thing missing is the fact, or not missing, but the only thing we have still to do is the fact that we have to get rid of this square root of 2 because we still have a square root in the denominator. So we're going to multiply the top and bottom by the square root of 2. So on top, we're left with 4 times the square root of 6x, because 2 times 3x is 6x. And then on bottom, we are left with 5 times 2, which is 10, and then y squared. Again, square root of 2 times square root of 2 is the square root of 4. Square root of 4 is 2, and that's why 5 times 2 gives you 10. The only thing left now is the fact that 4 and 10 can be reduced. 4 divided by 10 is the same thing as 2 over 5, and that will be our final answer.